Hey everybody, so I wanted to run through one of these statistical tests where we compare two proportions. Now I advertised this as we were setting up our hypothesis that doing the comparing two proportions is a little more difficult than doing just one proportion and comparing it to a value. So I want to go ahead and show you guys why this is true. Now, if you look at this here, we have 700 smokers randomly assigned to receive either an antidepressant or a placebo. 582 got the antidepressant, of which 262 quit smoking. 118 got the placebo, 34 quit smoking a year later. So I have that data over here. Let's just see the difference in these proportions real quick. So the first proportion is about 45%, whereas the second proportion is about 28%. So there's a pretty good improvement there with the antidepressant. So you think, that's probably pretty good. We we have some good results there. Let's actually run our statistical test and see how good we do. Okay, so to do this, we are going to do the pooled standard error and a pooled proportion. So to do the pooled proportion, what we're going to do here is we're simply going to add the number of participants. We already knew it was 700, and we're going to add the number of successes. And we're going to compute that pooled proportion. So I'm doing things with the keyboard here, but there we see my pooled proportion. I'm going to use the pooled proportion to compute a pooled standard error. So the standard error here is going to be the square root. I'm just typing it out, aren't I? The square root of the p times the 1 minus p divided by the n, exactly as before, except what we're going to do different here is this is going to be the n1. Then we're going to do the same thing with p and 1 minus p, and we're going to divide by the n2. The second number of total participants in that second project. So that's my formula for this pooled standard error. So let me actually do it now. So it's the square root. I'm going to be using this pooled proportion the whole time though. So 1 minus that pooled proportion divided by, now I'm going to use the n1, plus, again, the pooled proportion times 1 minus the pooled proportion divided by n2, the total number that got the placebo. All right. And there we go. There's our sample error. All right. So our standard error. So if we want to compute the z, what we're going to do here is we're going to do the difference of the two p hats. So p1 hat minus p2 hat. Technically, excuse me, I need to use some parentheses, don't I? I always forget parentheses on my equations as I'm going. Technically, we should subtract that from p1 minus p2, but the assumption here is that p1 minus p2, or p of the drug minus p of the placebo, was 0. Then we take all of that, so I need another set of parentheses. Let's use square brackets for those. We take all of that and we divide by the SE. So let me go ahead and do that real fast here. It's really actually pretty simple. It's going to be this one minus this one, and then the other part was 0, and so divide by that standard error that we computed. There we go. And let's go ahead and check that. Hey, we got it right. Great. Okay. So one more thing I need to do here, I need to convert that into a p-value. So to do that, we do that norm dot s. I need a dot, not an I. And we're going to use the distribution one. And we're going to tell it a yes. We want that to be true. And it gives me a big value. Remember, I have a positive z-score, and I actually want everything on the tail. So I'm going to go ahead and do 1 minus that value. Now this one is a not equal to, so I have to double the tail. So because there's two tails on this one, to get the p-value, you have to double it. So we take that and we're going to copy and we're going to paste. By the way, I'm just using the keyboard shortcut there. And let's check that answer. Perfect. I do suggest you copy and paste when using Excel and WeBWorK. It'll get pretty particular here. So the last thing to do is to make my conclusion. Our p-value is less than the alpha, so we reject the null hypothesis. And there seems to be evidence that taking the depression drug does have a different success rate. So you guys probably would have clicked one of those before you ever started. Let me click submit so I get the big green bar there. All right. Hey, look, I got one of the achievements. Keep in mind, everybody, that there's a little bit of trickiness here with using the pooled proportion and the pooled standard error. And then the other trickiness here is because you have a two-tail problem, once you get the tail, you got to double your tail to have both directions. Okay, happy studying. You guys got this. Keep working hard.